So if there's something that like I do on my calculator that I don't like do work for, will I still get full credit?
Can you give me an example?
Like, I think it's like one of the graphing things. Or like the 6th root of 64. We could do that in our calculators and not have to.
Number one.
Yeah.
Yeah.
Okay.
Did you guys have plus or minus there? Okay, I tried to make it obvious. I don't think the book is real consistent with this. I went back to the Algebra 1 book. It's inconsistent there too. So I tried to make sure we say roots so you know that there's more than one. All right, just make it obvious. That's why there's a plus or minus. Okay. All right. What other questions? Which ones would you like to go over, talk about, right?
I got to know about the absolute value of x. Because you got to put x in absolute value if you take the square root of it.
Was there one of those for that, or what number was that?
Not on here, but I remember doing it and not really.
So yeah, the absolute value means the same thing as a plus or minus. So when we do the plus or minus, like if we take the square root of both sides, say it's x squared, and you take the square root of x squared. Mathematically, there's two ways to write that: absolute value of x, or plus or minus x, because that absolute value allows for the x to have been positive or negative. For solving these on this quiz, we're going to go with the plus or minus. Okay, now there's that was an introduction. I'm not going to really test you on that for the quiz. I'll leave it at that. I don't want to take up too much time. Good question. Others? Right.
Can you go over 17?
Sure.
Like how you get the greater than or equal to 4?
What was her quiz? What was her key?
Oh,
between.
Yeah. I got x is less than 8, but I don't know the other part.
Did you graph it? Double check?
No, I didn't.
Okay, we'll do that. If I were to walk into class and just give you this problem right here and ask what the domain is of this graph, if this was equal to, okay? So imagine this graph right here. And I ask you what's the domain. Well, wasn't the regular radical x domain greater than or equal to 0? But it's been moved to the right 4. So now the domain of this graph is greater than or equal to 4, right?
Yeah.
So when you go to solve it, did you get x is less than 8?
Yeah.
Is that all you got?
Yeah.
Okay, so I'll show you what to look for now. All right. It's how to pair, and I'll show you the easy way to do it, which I've been doing in the notes, but just to kind of recap what we look for. If I graph, so we solved it by hand, we got x is less than 8. We go to the graphing calculator, we do 2 radical x minus 4. And then I'm going to graph 4. Now, before I hit graph, I'm looking for where that curve is what? Below a y value of 4. Do you all agree? Everybody agree? Hit graph. There's the curve. There's 4. When is it less than 4? When is it below 4? They crossed at 8. Do you agree? If I did second calc intersect, which I don't want to take the time to do, we all agree they're going to cross at 8. Yes? So is it safe to say, back to the original, this curve is below 4 forever less than 8? No, because where does that graph start? Its domain starts at 4. So Ryan, do you see how now x is less than 8 needs to be cut off at 4?
Yeah.
When x is 4? Does that make sense? Why?
That's where it starts.
Yeah, so Ryan, if you had x is less than 8, let's say I plug in 0. What's 0 minus 4?
-4.
Square root of negative 4. Uh-oh, there's a problem. I can't plug in 0 for x, but 0 is less than 8. Well, so then 0 might not work. So then I go to my graph and I say, well, the domain of this graph starts at 4. I better make it between 4 and 8. And why is it equal to 4? Because At 4, there's a point on the graph. It's equal to 4 at that point. Why is it not equal to on 8? Because I didn't want to see where it's less than or equal to, just less than. Right? So before 8, but after 4, including 4 and between 4 and 8. Kelsey.
If you just had like 3 greater than, or like x is greater than 3 instead of greater than or equal to 4, would that still work?
No. 3.5 doesn't work.
Oh, okay.
3.9 doesn't work. 3.999999 doesn't work.
Okay.
It doesn't. This 3.999999 minus 4 is negative. Questions? Ryan, was that enough for that one?
Yeah.
Now, I could get into the real nerdy way of saying, oh, the domain is greater than or equal to 4, greater than or equal to 4, less than 8, what's the overlap? But visually, people are like, oh, yeah, I can see it there, less than 8, but it doesn't even start until 4, so 4 to 8. That's the safe way to do it. Questions? Other questions and other problems? Kelsey?
Can you go over 8, please?
8. Yeah, so when you see a square root in the denominator, you have to multiply by what's called the conjugate. So I'm going to multiply by 5 minus radical 7 over 5 minus radical 7. And we get 5 minus radical 7 over, and I have to FOIL that out, 5 plus radical 7 times 5 minus radical 7. And when you FOIL those out, you get 25. Do you see how it's going to be minus 5 radical 7 plus 5 radical 7? They're going to cancel. Yeah. Minus radical 7 times radical 7, which is 7. 25 minus 7 is 18. So my answer, with no square roots in the denominator, is 5 minus radical 7 over 18.
Do you always change the sign even if it's negative at first?
Yeah.
Okay.
Because what's that pattern? If you change the sign and multiply by what's called the conjugate, different sign in the middle, the O and the I in FOIL are going to cancel. And aren't those the square root parts? The O and the I, we want those to cancel. That's what makes it cancel, multiplying by the conjugate pair. Different sign. Keep them coming. What other questions? Kelsey.
For 7, I like realize how to do it, but I'm just wondering why, if you like put them both to the 4th power, why doesn't it not just go to 3 over 2?
Put what both to the 4th power?
Like it's like 4 root of 3 and the 4th root of 2.
Yeah. So
if you just put them both to the 4th power.
That's a great question. Why can't I raise the numerator and denominator both to the 4th power? Can I ask you a question first? Let's get this cleared up. If I were to type this number into my calculator, beginning problem, and type the final answer in my calculator, are they the same numerical value? Would they be the same decimal? Beginning and end. Were we asked to change the problem? Like, were we asked to change the value of the problem at all? No, what were you really asked to do? Manipulate it to make it look different. Why aren't I allowed to raise the numerator and denominator to the 4th power? Or just the whole fraction to the 4th power?
Because when you multiply it by like the 4th root of 8 or the 4th root of 8, you're just multiplying it by 1.
Yeah.
So it doesn't actually change.
So we're multiplying by 1 in disguise, right? A fancy 1. If you raise the whole thing to the 4th power, you've made the whole fraction times itself. You've changed the value of the problem. Multiplying by 1 doesn't change the value of the problem. If there was an equal sign here and there was another side, we could raise both sides to the 4th power. That'd be fair. But not just, there's no 2 sides here. Good question. Why did we strategically pick 4th root of 8 over 4th root of 8? Leah.
You made it the 4th root of 16, which has you have a whole number as an answer.
Well explained. Perfect. Okay. Ready? Changing the problem, see if you guys can adapt. What if it was the cube root of 2? What would I multiply the top and bottom by if it was the cube root of 2? I hear was that the cube root of 4?
Yeah.
Charlie?
Yeah.
Is that right?
Yes, sir.
Confidence too. I like it.
Yes, sir.
Yeah. That'd be the cube root of 8. Do we know the cube root of 8? Yeah, it's a whole number. That's nice. That'll work out. Okay. So you have to pick those strategic values to make it cube root into a nice whole number or fourth root into a nice whole number. Okay. What other questions do we have? 15? Was there a certain part of it you want to see or just the whole thing? Okay. Double check. When you squared the left side, did you get x squared plus 10x plus 25?
Yeah.
Okay, and then on the right side, did you get 5x plus 39?
Yeah.
So then which way did you move the terms? Did you move them to?
I tried to like divide this by 5 and then subtract it to 0.
Gotcha. All right, other questions? Keep them coming. Love ya. 16. Was there a certain part of it or just how to know what to do?
It's more of a question than that. Well, I did like the 7 times or 7. Oh, that's what I did wrong. I didn't raise it to the 7 halves.
Did you multiply by 7 halves?
Um,
You guys see how, remember, we're raising it to the reciprocal power so that when the exponents multiply, that's the tricky part. Students forget that all the time. It's not multiplying by 7 halves in the front. The exponents are getting multiplied together, right? So be careful there. So on the other side, we're not multiplying by 7 halves. We're raising it to the 7 halves. And again, if you have an old calculator like mine, you have to raise it to the 7 halves in parentheses. In parentheses. And that one, a decimal answer is fine. I think we rounded to the nearest hundredth on that one. Other review questions? Keep them coming. As you're looking for other questions to ask, here's what I'll say. I made copies yesterday. It's the front and back of a page and the front and back of a second page. It's a long quiz, okay? You can blame Mrs. Naples. I'm just kidding. I'm recording this. Don't tell her I said that. It's a longer quiz. So what I will say is you really can't be like second guessing your knowledge of the rules or else you're going to get stuck and you're going to get confused. But if you do get confused, go just move on, come back to it, put a star next to it. That's the good news is you have a graphing calculator for the whole thing. Really, we should have taken the graphing calculator away for parts of some of the rules and stuff like that, but we didn't. So you'll have the calculator for the whole part. Just know your rules. Go back and study the rules and practice them. I bet if you went back to the guided notes and you had them all out for 5.1 through 5.4, had all the guided notes out and kind of covered up the examples and resolved them, I bet they would be like, oh, I don't remember even doing that problem. That's a good review problem. Those are ways to practice the rules. If you just think you're going to sit down and read the notes, I've been guilty of this before. It really messed me up in math. I took 16 math classes after Calc 1 in college. And if I ever tried to just study by reading the notes like I would for social studies, it doesn't work, okay? I can't just memorize facts for math. I have to practice them. You can't just stare at them and hope it gets committed to memory. You have to practice them. So as you look at the rules, don't just read them. That's probably a good practice too, but practice them too. All right? What other review questions you want to talk about? Ryan?
For number 2, you know how you like take the fourth root?
Fourth root, yep.
When you take like the root, is it always plus or minus?
Well, if it's an even root.
Okay.
If you're taking the even root, you're uncovering. If I do it to the left side, right, that x plus 7 could have been positive or negative because I'm uncovering it. So we just automatically move the plus or minus to the right side. So if it's an even root, plus or minus. If it's just the cube root, nope, just leave it plus. Or if it's the cube root of a negative number like -8, it's just -2. It's not plus or minus 2.
If we don't finish the test on time, like, are we still gonna have to turn it in?
Yeah. Again, this is my first time teaching this in a long time. She's done it. She gave something similar last year, and so I trust that she put the correct number of problems on that's fair. She's very good at that. If she feels like she did something that wasn't fair or like wasn't enough time, she goes back and she reviews it. We actually met together and we talked about the quiz and we went over it and how long it is, and we felt like it's a fair length. It is longer than usual, but I bet we would all agree some of these problems go very quickly, right? But you need to be automatic on the ones that you should be automatic on. Like transformations, you should be able to look at and be like, oh yeah, write 1 down 3. Andrew.
How many questions are on the test?
I'll need to double check, but man, I had like a 17 like in my mind, like stuck in my mind for some reason. 16, 17? Oh yeah, 17 stuck in my mind for some reason. Looks a lot like the review for some reason. All right. What about the graphing ones? If you're asked to describe the transformation in graph, again, pick strategic values for x. Yeah, you're going to have a graphing calculator, but pick strategic values for x. Like, do I know the 4 through the 15? No, but I know the 4 through to 16. So pick a value for x that will make a 16 under the 4th root, if it's that problem, right? Sarah.
Can you give us like a practice problem of like a different, of like the graph type of question?
Like 11 or 12 you're talking?
Or no, not 12, like 11. That's where we have to graph it. And like find the domain and range.
Yeah. Like that?
Mm-hmm.
You don't have to do both of these, just kind of, if you have time, you want to do both, that's fine. So this would be a graphing domain range kind of problem. I'd want to see that table of values. Maybe we should only let you use the TI-30s on this one. It's too easy with a graphing calculator. I heard you guys thought the honors class this year was too easy. One word challenge. We're history. That's what Vince said. I don't know. That's too easy.
What did you get?
All right. We don't have a name. We don't have a name for this point yet. But do you agree the x cubed graph looks something like this? And that point right there, we don't call it a vertex, but that point is at 0, 0 normally. Do you agree? Everybody with me on that? So if that were the original graph, the parent function, that new point, we're not calling it a vertex, but that new point is at what? This graph got translated to the right 4, up 5, and at some point it also got reflected across the x-axis. So now we know the graph's going to look like, let's see if the magic will happen here. That's right. So something like that. It was like that. It got moved to the right. 4, up 1, 2, 3, 4, 5. Yours looks something like that. No? What happened?
I don't know. I use the same points as
Let's graph it. What calculator are you using?
you.
Oh, that's tough to graph on.
Well, no, it's to find the points, not bigger.
All right, let's plug in some values. Let's do the easy one. I know what 4 is going to be, right? If I plug in 4, I know my x's are going to be out of order. Deal with it. All right, 4 minus 4. Cube root of 0 times a negative plus 5. So 4, 5 is that point, which we knew. What's another strategic point that I know the cube root of? What do I plug in for x? 5? Because 5 minus 4 is 1, and the cube root of 1 is times a negative 1 plus 5? 4. So 5, 4, which makes sense because it's coming down now. Now, my graph is not to scale. 5, 4. What about to the left of 4? What would be a good one? I heard 3 in my mind. Good, right? Good answer. What's 3 minus 4? Negative 1. What's the cube root of negative 1? Negative 1 times a negative? Positive 1 plus 5? 6. So 3, 6 is a point on that graph. Again, if you're nervous on the quiz and you're like, I don't have time for that, I don't really want to plug all those in my head, I want to get a table of values from my calculator, you're graphing it, you're hitting second calc value, type in an x, hit enter, it gives you out a y. Type in those x's, it gives you out a y. Make your table right from that. What's the domain of this graph? All real? Range? All real. We good? All right, next one. It took the square root graph. It got translated to the left 4, down 2. It also got vertically stretched by a factor of 2 at the beginning. Okay, so the normal square root graph would look like this, but it got translated left 1, 2, 3, 4, down 2, and because I'm not drawing it to scale, it already got stretched by 2. All right, magic of math. There, one got stretched by 2. some strategic values for this one. Well, we don't even need to type it in, but what's negative 4 plus 4? 0 squared root of 0, 0 times 2 is 0 minus 2. Oh, we knew that. It was that starting point was at negative 4, negative 2. What's another good number to type in? How about x is 0? 0? 0 plus 4 is 4, square root of 4 is 2, times 2 is 4, minus 2 is 2. And so forth. You can keep going. Domain. Careful. Good. It starts at negative 4 and goes to the right. How do I write that with an inequality? X is greater than or equal to negative 4. Range. The y's start at negative 2 and go greater than or equal to negative 2. Make sense? All right, quick little easy to apply concept here. If you know the domain and range of radical x untransformed, the parent function radical x, and you know how to shift it, left 4 down 2, you've also just shifted the domain and range. The domain got shifted to the left 4. Ooh, so now it's greater than or equal to negative 4. The range got shifted down 2. Okay, greater than or equal to 2. See it? Now be careful about the reflection. You need to know if it's when it got reflected. It's not going back.
But you can have a radical.
What's that? What? It's going to take long. You can bring your lunch in and we can do it. All four. How many of you guys are going to be missing tomorrow? Missing tomorrow for a visit. All right. Any other questions I can answer from the review?
That's irrelevant.
All right. You guys got this.
I gotta